let's take a look at a few more complicated composite functions and continue working on finding the domain of the composite functions. So first thing first, when I want to find this composite function, they're asking me to take the g function and plug it into the f function. So when I do this, I'm literally going to take this g function over here, x minus 1, and plug it into the x of the f function. This is what it means to do the function f composed with g. So when I start to write this out, I will write out the f function, 2 divided by 2 times x, but in place of x I'll put a blank parentheses, and then plus 3. So in that blank space, as I mentioned, instead of writing x, I'm going to write the g function, which is x minus 1. So let's go ahead and simplify this a little bit. I can go ahead and distribute that 2 on the bottom. So I get 2 over 2x minus 2, and then plus 3. And then combining like terms on the bottom, I get a final answer of 2 over 2x plus 1. So there is my composite function when I do f composed with g. Well, the second part of this problem then involves stating the domain. And if you watched the last video, you know there's two things we need to check for. One, we need to check for the domain of this second function, so the g function. Okay, so if I look at the g function, I see that, well, x minus 1, there's really no domain restriction on that. x can be anything I want it to be. So x is all reals. From negative infinity to positive infinity, I can subtract 1 from any number. I also, though, need to check the domain of my final answer, my composite function. And this time, there is a domain restriction. X cannot be anything I want it to be. I don't want to divide by 0. And so some of you may be able to look at this and just know what we don't want x to be. For the rest of you, let's go ahead and actually set the denominator equal to 0 to figure out what our very bad number would be. If I subtract 1 from both sides then, and divide by 2, I find out that x being equal to negative 1/2, would get me a denominator of 0, and I don't want that. So my domain is actually x cannot be equal to negative 1/2. So now to find our total overall domain for this problem, I need to consider both of those domains. This domain and this domain up here. So putting those pieces together, well, the first one was all reals, there's no problem there, but my second domain, I said x could not be negative 1/2. So let's go ahead and state a final domain. I'm going to do this whole set notation thing. So x such that x cannot equal negative 1/2. Okay, we'll take a look at one more example. Some of you may be wondering, well, why do we even care about this first one? Let's take a look at one more example to see where that can come into play.